Okay, welcome everyone. Let me introduce myself. My name is Mark, and I also studied at the VU. I studied economics and business economics. And after my education, I started tutoring organization Sophistès. And I'm now doing it for at least 5 years. And I've given different courses, for example, the courses from economics, but also courses like business mathematics, business statistics, finance, accounting. So I always say teaching is my passion. It really gives me energy, and that's why I do it full time. And I'm here to help you with the business mathematics first week. So what are we going to do today? Today we will discuss the summations and products. So that's only the first part of all the material you have to know, but it's a pretty difficult part. And after this session, you can do the summations and products easily. So how are we going to do it? I'm going to tell you all the theory you need to know. And after I explain the theory, I will show a lot of examples and I will use the whiteboard function to explain it. And then after my examples, I will let you guys do some action questions. So that's how we basically are going to set it up. So theory, examples, action question. Those three things we will do. Okay. So about the course. So this trial session is obviously taught via Zoom, but after this session, we will have weekly sessions each week, and then they will take place at the camp. And if you, I will ask you guys a lot of questions, and I would just do that to see if you understand it. So I will sometimes call your name, and then I might ask you a question, and then you can just turn on your microphone to answer it. And also for you guys, feel free to ask your questions as well. So I want to make this session as interactive as possible. So always feel free to interrupt me and to turn on your microphone. You can, if you are a bit shy, you can just ask your question in the chat, but I also appreciate it if you just turn on your microphone to ask your question. Okay, so let's start. Everything I'm going to explain is also in the summary, but I will use the whiteboard function a lot because I like that way of teaching it. So let's go to the whiteboard. We're going to talk about summations. And I will first start with the most easy summation. So for example, you always have an index letter. For example, I, but you could also use J or K. And then this will be the starting value. And then here above, we will put the upper value. Let's say it's a 3. And then at this spot, I will place an expression. And the expression can be anything. For example, the I itself. And then you will write down I is 1, I is 2. And notice that it starts at 1 because this thing here is a 1. And then all the way up to I is 3 because the upper value is 3. And then because this is a summation sign, another product operator, I put pluses in between. And then I look, if this is I is 1, what will the value be of this expression? Well, this one is the easiest. So it's just 1, 2, 3 is 6. So that's basically what a summation does. It helps you to sum a series of numbers. Okay, let's make it a bit more difficult. What if I do it like this? I is 2 all the way up to 4. And I will do I plus 2. Then you start again. So it always helps to start with those numbers here above. So you look, okay, it starts at 2. So I start with I is 2, I is 3. And then the last one will be I is 4, because that's my upper number. And then since this is a summation, another product operator, I put pluses in between. I get a question from Tim. How and where can we rewatch this recorded lesson? I will put it on YouTube and then I will share it with you guys. So I think that works. And maybe I can even, the benefit of that is that I can even specify what I'm explaining at which moment. Because after this session, you have like 2.5 hour-long video. So maybe I can specify what I'm doing each minute, so it's more easy to watch it back if you only want to watch a part of it. I think that works better. So I think I would just put it on YouTube then. Okay. So this is what we start with. And now we're going to look, if I is 2, what will be the value of this expression? And that will be 4, right? And if I is 3, this will be 5. And if I is 4, then this thing here will be 6. Then we add it together. So 4 plus 5 is 9. And 9 plus 6 is 15. So that's basically how a summation works. Then I will now ask one of you guys to help me with that. So Natalie, would you like to help me with the next one?
Yes.
Here it goes. I is 2 all the way up to 5. And then 2 times the y squared. How do we start?
2 times 2 squared.
Yeah, so you first want to write down this thing here, right? Because that helps you. What kind of sign do we put in between?
Plus.
Pluses? Yes. So I put pluses in between. And what did you say? If this is 2, then I get
2 times 2 squared.
So 2 times 4, and that is
8.
8, right? Yes, very good. Then the next one, if I is 3.
2 times 3 squared.
And 3 squared is
9.
So 2 times
18.
9 is 18. And then for the 4 squared?
16, so 32.
Very good. And then this
25
one?
times 2 is 50.
Yes, very good. All right, let's see if you can do some arithmetic. So 18 plus 32 is
50.
50. And 50 plus 50 is
100.
Plus 8.
108.
Very good. Thank you, Natalie. All right. I will do now some other thing. What if you only have a constant? Jason, would you like to help me with that one? With the next one?
Yeah, okay.
What if I only have a 3 here? So there's no I in it. Do you see that? So this is called a constant because my index letter is the I. And in this expression here, you don't see the I. So I always start with I is, what's the lowest value for I?
2.
2. I is 3. I is 4. I is 5, right? And then I put pluses in between because it's a summation sign. And what will be the value here that I will put?
3.
Yeah, just the 3, because if I is 2, then the 3 is just a 3. And if the I is 3, what do I then put here?
Also 3.
A 3. And
Yeah,
a 3
3.
here.
3.
And what do we get?
12.
Yes. We basically have 4 times the 3 is 12. And I will eventually show you a trick how to find this 4, but I will do that later this session. Very good, Jason. Okay. Then I will shrink this a bit. 1 second. Gives me some more space. All right. One more. That is the product operator. So let's say that, by the way, we can also just do K, just to show you that I can also do something different than K. Who will I ask for this one? Franchika, would you like to help me with this one?
Yeah.
How do we start?
You write k equals 2 and then k equals 3, 4, and 5.
Yes, very good.
And then 2 plus 2 is 4 plus.
By the way, what kind of sign should I put in between?
Sorry, times multiply.
The times, yeah, because we now have a product operator. That's the only difference. For the rest, it basically works the same.
Yeah.
And what did you say?
So 4,
4,
5,
5.
6, and 7.
Yes. Would you like to calculate what we will get out of this? You might use your calculator.
Yeah, 840.
840. You're quick. Is that correct? I didn't check it. Did somebody else also calculate it? Could somebody verify it? Nobody? Did nobody check it?
Yeah, I got the same.
Correct.
All right, great. All right, thank you. So that's the introduction of how to work with summations and product operators. Now we're going to look at some properties. So here you have the summary. Oh, wait, first, maybe we can do some action questions. So here I have the first action question, and I will let you guys do it on your own. And then you can put the answer that you get in the chat. But one important thing, send it in private to me so that the other students cannot see the answer. So in this Zoom chat, you can send your answer to me in a direct message, but do it in a direct message, not in a public message. Okay. And then I can also see how far you guys are. I already got the first answer, and I think it's correct, Pashika, if I remember correctly. I think also that's correct, Julian. Yes, sir. Very good. So you already got 3 answers. Would you like to help me, Sophia, with this question? Would you like to help me, Sophia, if you're there? I see something in the chat. Ah, you have some problems with your Wi-Fi. No problem. Boris, would you maybe like to help me?
Sure, but I didn't really find out yet, but I can help.
Maybe we can do it together.
Okay,
What's
sure.
the first thing you start with?
You write it down like you did there.
The K is
That's fine. And then you start with k is -1, k is 0, and k is 1.
very
And then
good.
you fill it in. So you get 2 to the power of -1.
Mhm.
And then
Times or
times.
plus?
Sorry?
Times.
Times.
Yeah,
and
times indeed.
2 to the power of 0, and then 2 to the
Mhm.
power of 1. And I thought it was 0, the answer, but I'm not sure.
No, because what will 2 with the power of -1 will be? That will be 1.5, right?
Oh, yeah. Yeah.
And what will be 2 with the power of 0?
0.
No,
Right.
it will be 1. So if you
One?
raise a number with the power of 0, it will always be 1.
Oh, okay.
And if you do something with the power of 1, the power, you don't have to
Yes.
write it down, right?
Yeah.
Okay. So what would we get?
1.
Yes, very good, Jason. Hey, Boris. Very good.
Okay, it's clear. Thank you.
You're welcome. Is this one clear for everybody? Are there any questions? No? All right. So the answer is 1, and everybody who submitted the answer had it correctly. Okay. Here's the next question. You have some notation that you maybe don't understand yet, but don't worry about it. You will learn it along the way. The only thing where you have to focus on is that you have to find this thing here. You see that X, and for X, you can fill in the K. And you have to simplify it as much as possible. But there's only one thing I want to tell you. Do you guys remember that sometimes you could have, for example, that I choose I is 1 all the way up to 3. But then in this expression, you don't see the I. So for example, you have a 2. In that case, you did 2 plus 2 plus 2, right? It was a constant because in this expression, you don't see your index sign. In that case, it's a constant. That's just the thing I want to point out. So here, just to help you guys a bit, here your index letter is the J, but your expression doesn't have a J. So it's a constant here. So I hope you understand what you have to do with that. So because the index sign is not here in the expression, it's a constant.
Do we have to make this question ourselves?
Yes. I just want to say that so you can
Oh, okay, sure.
start. All right. And again, if you have the answer, you can submit it via a direct message in the Zoom chat. All right, I already got some answers. I don't think that's the correct answer, Julia. But you can try to figure it out some more. No. Let me see, Tanish. Your denominator is not right. So I agree with the numerator, but I don't agree with your denominator. Stella, would you like to do this question together?
You asked me?
Yes. Would you like to do together?
Sure. I don't know the answer because I'm not really sure how to do this one, but it's fine.
No worries. Just tell me what you do know. So how do I start? Let's first focus on this part.
Well,
J is
yeah, J is 1, J is 2, and J is 3.
What kind of sign do I put in between?
You
Time sign or plus?
yes, thank you. Forgot the word.
A time sign.
Yeah, thanks.
Very good. And then what will be the value of K if J is 1? It would just be k, right?
Oh, yes. Yeah, that
Because
will
if
be,
there was a j here, then it would be 1. But since
Oh,
there's
okay.
not a j here, it would just be k, right? It's just like this example where you have a constant. You see that?
yeah, I see. So it will be just k times k times k then
Exactly. And that is k with the power of
3.
3. Very good. And here we can do the same. J is 1, j is 2, j is 3. But what kind of sign will be in between here?
Plus each other. You add it.
Yeah. And then here you get k, k, k. So
So
k
it will
plus
be
k plus k is just
3k.
3k. And now we're going to divide it on each other. So our final answer is k with the power of 3 divided by 3k. Do you know how I can simplify this?
I'm not sure, to be honest.
Shall I give you an extra step? You can see it like k times k times k divided by 3 times k. So you can basically cancel out one in the numerator and one in the denominator, right?
Mm-hmm.
And then k times k is,
K with the power of 2.
yes, and the 3 is just a 3. So this is your final answer.
Okay,
Thank you, Sterre.
thank you.
Are there any questions about this question? No questions? Okay. Can I erase it? All right. Now we're going to make it a bit more complicated. We're going to talk about the properties of summations. For this course, business mathematics, you have to know 5 different properties: additivity, homogeneity, extending terms, the constant term, and the telescopic series. What I'm going to do is the following. I will write down the definition of the properties, and then I will give you some examples so that you know what the definition does. And then I will top it off with some exam question that you can practice. Okay, so I will not do additivity because that one is pretty straightforward, but we will focus on the first one, and that's homogeneity. Okay. So homogeneity. Let's see what kind of example I chose there. Oh, I misspelled it, by the way. Here should be it. Okay, so the first property is homogeneity. Let's start with the definition of it. The definition is that if you have a summation and you're multiplying your expression with a constant, then you can basically put the constant in front of the summation, like this. And it works a bit like you're putting the constant out of the brackets, but you will see it with the example. So let me give you an example of the property homogeneity. Okay. 1 second. I think somebody is not muted, so I fixed it. So the example, and I will just take the example from the summary. I think that was yes. So you, for example, you have I all the way up to 3, and your constant is the 2, and the xi would just be I. Okay. What I'm going to show you is that I eventually can write it down like this: 2 times the summation of I is 1 all the way up to 3i. So I'm going to show you that this will be the same as this, that I can just put that constant, the 2, in front of the summation. That's what I'm going to show you here. Okay. So we just start like we normally would do. I do I is 1, I is 2, I is 3, and I put pluses in between, right? Because we are working with a summation. And then I get 2 times 1, 2 times 2, and 2 times 3. That's what I get here. But what you will see is that all the terms have this 2 in common. So I can basically get a 2 out of the brackets. And then I get this 2 times 1 plus 2 plus 3. So I took that 2 out of the brackets. Do you guys agree with this step, that I'm allowed to do that? And what you're seeing here, that is just the 2 summation of I is 1 all the way up to 3. So that's what the homogeneity tells you. If you have a constant like this, you can basically just put it in front of the summation. Is this one clear for you guys? And it sometimes helps you to simplify summation. So that's called homogeneity. Did you guys write it down? Then we go to the next property. And that's the extending terms property. And the extending terms property, that one is a bit more difficult, especially the exam questions about it. And I have multiple exam questions in the summary, but I think the questions about the extending terms are the most difficult. Let me show you. Okay. Extending terms. So that's the second property I'm going to show you. The definition of the extending terms property is that you have a summation from I is 1 all the way up to n. And then you add another one. But this one starts not at n, but at n plus 1. So this one continues on the previous series. And then it goes up all the way up to n plus m. And what the property is telling is that those two summations are equal to I is 1 all the way up to n plus m. So this is the definition. You should basically learn it by heart, but I hope it will make sense to you. So let me give you an example. You can, for example, have I is 1 all the way up to 3. And then that the xi is the most simple form, for example, I. And then what number should be here? Does anyone know? Here I should have a 4, very good. And let's assume that this would just be a 5. Then here, according to the rule, I get I is 1. Notice that those two are the same. So if this one is a 5, then here you should also have a 5. So according to the rule, this should be true. So let's see if this is indeed true or if it's not true. Okay, according to this summation here, you get 1 plus 2 plus 3, right? That's what this summation does. This summation here is 4 plus 5. You see that? And then this summation here is 1 plus 2 plus 3 plus 4 plus 5. So it is indeed true. So the question is now, what do you have to know about it for the exam? So after you wrote this down, I will tell you what you should be able to do with it. So I will just give you a few seconds. You should be able to make some corrections on it. So on the exam, for example, they might give you, instead of a 4, I'm now going to misform the formula. So this is what you should write down, and I'm going to make some adjustments so that it is not true anymore. So for example, instead of a 4 here, maybe you get a 3. What's the problem that we have now? Well, this summation will include the 3. But now, since this is a 3, another 4, you here get a 3 extra. You now have the 3 twice. So the question is, how should you correct for that in the action question that I'm going to show you later? Well, because now the 3 is, you have 3 in your series twice, you should subtract a 3 to correct for it. So you just do -3 here, and now it is true again. So what I want you to show, what I want to show you is that if here is a 3, the 3 will be counted twice, and then you should do a -3 here so that it is true again. So you should be able to make corrections here. Okay, so that's the first example of how you can apply correction to this formula. If there are no questions about this one, I will show you another thing here, and then you have to tell me what kind of correction you should make.
Wait, sorry, one quick question. This formula, are we given that in the exam, or do we have to remember that
No.
ourselves?
You have to remember it. I'm sorry.
Okay.
I think there was a time that we had some formula sheets. Well, actually, I'm not certain anymore, because in my time we didn't have a formula sheet.
Mhm.
Then you got a formula sheet, but then with Corona they abolished the formula sheet again.
Okay.
But maybe now, since you guys have probably an open exam, right, or not?
Yeah.
You guys have, then maybe they will give it again. But if I remember correctly, this formula was not on the formula sheet, even though, even in the time when they did have it, it was not on the formula sheet. So
Okay.
I think this one you should just learn by heart.
Okay, thank you.
So let's go back to the original situation. Now it is how it's supposed to be. I'm now going to do something else. This 3, I will turn into a 2. What's the problem here? What do we have, double, or what are we missing? Now
We
can
are missing
correct
the
for
3 now.
Yeah, we're missing the 3 now. So how can I correct for it? Well, I can simply add, which number, of course? I can simply add the 3, right? And that fixes the problem. So for example, if this one is a 2, you can also simply just add a 3 here. Do you see that? So you should be able to also apply corrections to the formula. Even though you don't have n and the n+1 structure, you sometimes can fill in the missing values, or you can subtract the numbers you have twice. That's the thing you need to do with the action question I'm going to show you in a few seconds, in a few minutes. Okay, so is it clear what this formula does and how you can apply corrections to it? Is that clear for you guys? Okay, that's the extending term formula. Then
I have a
here,
question. I have a question.
oh yeah,
Can you go back one slide, please?
of course.
You can also change the I at the second sum to 3, right? And that will also fix it.
Yes, exactly. That is also possible, that you make this a 3, of course. That's a
Okay.
very good point.
Okay,
Very
thank
good.
you.
You're welcome. Okay. Then the constant term property. So the constant term property is maybe my favorite. I will just give you an example again. The definition of the constant term is as follows. You have a summation from I is m, and m can be any number. And then here you have your n, and here you have a constant. So this thing doesn't include an I. So this C does not include the I. So it's a constant. And according to this rule, you get n minus m plus 1 times C. And I will give you an example why that's true. So for example, if you have I is 2 and the n is 5, and here you have the 3. Maybe you remember this example. What you normally did was you would do I is 2, I is 3, I is 4, and then I is 5, because that's the upper boundary. And since it's a summation, you will put pluses in between. And then you would do 3 plus 3 plus 3 plus 3 is 4 times 3 is 12, right? But you can imagine that if it's a 5, then it's doable, right? Okay, 4 numbers, that's doable. But what if this was 500? Then it would be a lot of work to write this whole series out, right? So you want to have some sort of formula for it, some formula that can give me this value of the 4. And to get this 4 that we're seeing here, to get this 4, you can apply the formula n minus m plus 1. Because my n is just 5. My m is this 2 here. And the 1 is always a 1. So this here, n minus m plus 1, 5 minus 2 plus 1, that gives me that 4, right? Okay. So for example, what if I have this one? What will be the value of this number? Here, it's too much work to write out the whole series. But fortunately, we have this property that we can use.
Will it be 100 times 5?
Yes. So you're going to apply 101 n minus m plus 1. So n minus m plus 1 times the c, which is 5. And that indeed is 100 times 5, right?
Mm-hmm.
So in exactly. That's the nice thing about this property. You don't have to write out this whole series. You can just simply calculate it with this here. So is the constant term property clear for you guys? Yes? And you see the benefit of it. Okay. Did you guys copy it? Yes?
Yeah.
All right. Then the last one, that's the telescopic series. So here you have the telescopic series. And maybe this one is the most complicated to see if you only see the definition, but I think it will be clear in a second. So the definition of it is as follows. The telescopic series. Okay, the definition is as follows. You have the summation of I is m all the way up to n. And the structure you have to be looking for is xi minus xi minus 1. So this is the structure we're looking for. And what it will tell you is that if you have this structure, and I will show you some examples so that you can recognize the structure, everything will cancel out except for your n term and the m minus 1 term. And I will show you some examples of what we mean with this definition. Okay, so for example, if you have the summation of I is, what did I use in the summary? I is 3, that's fine. All the way up to 5. Then you have the I squared minus the I minus 1 squared. Then I will show you what happens. What this rule predicts is that I can take this xi and I fill in the n for it. So I will get 5 squared So I fill in the n at the spot of the I, minus the m in this spot minus 1. So the m is 3, minus 1 is 2. So this is what it predicts. So the telescopic series tells me that this is my final outcome. And I'm going to show you why that is true. And I'm going to show you some examples that you can recognize it in the future. Okay. So let me show you. You can now start with I is 3, I is 4, I is 5. And then we put some pluses in between. I think I have to make a bit more space because else it will not fit. And then here you get a 3 squared. And here you get a 2 squared, right? Because 3 minus 1 is 2. So that's what the first term will be. Then if I is 4, I get 4 squared. And then 4 minus 1 squared. And then here I get 5 squared. And then 4 squared. So do you guys agree with this so far? Yes. And what you will find is that everything cancels out except for the xn and the xn minus 1. So you will see that this 3 squared will cancel out with this negative 3 squared. This positive 4 squared will cancel out with this negative 4 squared. So the only thing that will be left is this 5 squared here and this 2 squared here. And hey, this thing is just the n squared. And this thing is just the m minus 1 squared. Do you see that? And that's exactly what this rule predicted. Is this clear so far? Yes?
Yes, it's clear.
Now I will show you the power of this rule. Because what, for example, if I make this a 4, and I'll make this a 12. Now it would be a lot of work to write out this whole series because there are a lot of numbers in between the 4 and the 12. But what will be the outcome?
Would it be 12 squared minus 3 squared?
Yes, that's what it will be. And maybe it's also interesting to calculate the numbers, by the way. It's 25 minus 4 here. So that is 21. And what will I get here in this example?
Uh, 135.
135. Because this is 144 and this is 9. So indeed 135. Okay. Is this clear for you guys? Shall I give you another example with a different functional form? Let's see. Let's see what we get here. I will give you guys some time. What do we get here? Does anyone have an idea? What do we get here? Maybe I can ask Adam. Would you like to help me, Adam? Are you there? No. Okay, I will ask Julian. Julian, would you like to help me?
Yeah, sure.
What do we
So,
get here?
first 2 to the power of 6,
Yes.
and that's 64. Oh, don't have to say that yet. Then
Mhm.
2 to the power of 3 minus 1,
So
2.
2, right? Very good. Which is 4.
Equals
So what is my final outcome?
60.
60. Very good, Julian.
Thank you.
Is this clear? Is this rule clear for you guys? Yes? Right. Then I think you guys are ready for some exam questions.
But I have a question.
Okay.
Is it always clear when we have to use which rule, or is it given on the exam, or do we have to see it ourselves?
You have to see it yourself. So you have to
Okay.
recognize the structure, right? You see the I and then minus something with I minus 1, right?
Okay.
And that's how you can recognize it.
Oh, so that's for all the questions. That's just the basic form, and then if you know the basic form, you are always okay.
Yeah. I'm going to show you some exam questions. They
Okay.
might recognize it. This is a tutorial exercise. This is relatively easy. So just take some time and then you can send the answer in the chat via Zoom. So you can send it with a direct message to me. I think that's correct, Julian. Very good. So I already got the first answer. Yes, very good, Boris. Yes, Natalie. Yes, Panchika. Very good, Sterre. Okay. Tanish, would you like to help me with this question? Would you want to do it together?
Oh, yes, sure.
Did you, how, yeah?
Yeah, so first you use the rule, which is the constant term rule.
Mhm.
So you can just do n minus m plus 1, which is 10 times 2.
Yes. So here you can use this rule. Ten minus the m is 1, and then plus 1. So basically it's just n times c in this specific case. So you get 10 times 2 is 20, right? So here you had to recognize that you could use the constant term rule. All right. Very good. Is this one clear for everybody? Yes? Okay. What went wrong with you, Sophia? How did you get to 100? You don't want to tell? Ah, you multiplied instead of subtracted, I see. No worries. Okay. Then here is a pretty difficult one. I will first help you guys get started. Which property do you think you have to use? If you just look a bit, it goes all the way up to 23, and then it starts somewhere around the 24, all the way up to the 45. And then you want to know it from 1 to 45. Which rule comes in your mind?
Is it the
Extending term.
extend?
Yes. And how did that property go? Do you remember that? Start from I1 all the way up to N, right? And then it starts at I is what? N plus 1, right? All the way up to N plus M. And then I is 1 all the way up to M plus M. So you have to recognize that you can apply this property to this question, because you sort of see that it goes in that way. What do you guys think my N is? My N is 23, right? The xi is just I. And it should be a 24. But there's a problem, we don't have that number. So I will just give you some time to figure it out. But it is a pretty difficult axiom question. So see if you can solve it. So don't feel bad if you don't know how to solve this one.
What was the n plus m again? Like, what is the m value?
The m value,
Yeah.
that would be 22. So
Oh,
n is 23, and then the m is 22. But it's not that important or something, because the n plus m is the 45, right?
okay.
So, but this is not that interesting. I'm going to give you guys a hint. And maybe I can ask Boris to help me with this one.
Yeah, sure.
Boris, do you know the value of this thing here?
Yeah, I thought it was Yeah, but I didn't calculate it yet because it's quite a lot of numbers. Which
Oh,
I'm not
by the
really
way-
sure what I'm not really sure what they're trying to ask. That's for me a bit
Okay.
vague.
We want to know this value here. That's the value we want to know. Do you see that?
Yeah, that I understood. But
So
I
we
know
need to, yeah.
I thought we had to do like 1 + 2 + 3 + 4 + 5 + 6 + 7. And then
No, that's not possible. Because the xi can be anything. We don't know what xi is. It doesn't necessarily have to be I. So if it was
Oh.
I, then you could do 1 + 2 + 3, but now it can be anything. Maybe it's I squared or whatever. So we don't
Oh,
know
yeah,
what xi is. But what do we know about this value if you read the question?
That it is 34.
Yeah, so I can write down 34 here. But the problem is that this thing here isn't exactly given in the question. So for this thing here, we only have it with a 23 in it. Do you see that?
Yeah.
So here you have a 23, but we actually need a 24. So instead of doing it at 24, I can also write it down as a I 23. Is everybody still able to read this here below?
Mm-hmm.
But what goes wrong if I take the 23 here and I include 23 in this summation?
Then you have too
Then
much.
yeah, I counted the 23 twice. So how do I correct for that?
You subtract the 23 on the
Yes,
value
I
of 23.
subtract the 23. And if I do that, now I'm able to figure out the answer. Because then I get 34, which is this 34. From this thing, I know the value. What is that value? If you look at the question.
It's 6.
78, right?
Oh, I
This
thought
thing
you meant
here
the
is 70.
X23. Sorry.
Oh, no, that's an actual. And indeed, this thing here, that is the 6.
Yeah.
So I basically could divide this thing here into 2 components. Do you see that? So we
Yeah.
divided this thing into 2 components. And those 2 individual components, there from those 2, I know the value, 70 minus 6. And now I can get my final answer. What do you get?
Let me see. I get 106.
Yes, 106.
Okay.
Very good.
So
And yeah.
I have a question. It's not
Mhm.
possible to calculate this sum or to do math with the sum if you don't have the given values.
What do
So
you mean?
if we didn't have 78 and 34, it wasn't possible to.
Oh yeah, then you would write down impossible indeed.
Okay.
Then you don't have enough information. Yes, because you don't know the xi.
Okay, then it's clear for me. Then it's
All right.
because I didn't understand it. I thought we had to calculate it ourselves.
Yeah. No, you had to come up with this correction to the formula. This one was a really difficult action question. And also notice, guys, that we didn't use this thing here. It was just given, but we didn't have to use it.
But if there wasn't if it was I and not xi, it would be the thing that I did, right?
Sorry, could you repeat it?
So if it wasn't xi but it was I only.
Yeah,
So
then you could just calculate it.
Okay.
But then
okay.
then it was really easy. Then it's just 1 + 2 + 3 all the way up to 45, right? That would be too easy.
Yeah. Okay. Okay. Thank you.
You're welcome. And then I see that Adam raised his hand.
Yeah,
have
I
a
already
question?
lowered it. I already answered my own question.
Oh, okay, great. Are there any other questions? Because this one was pretty difficult. Okay. Then we're going to do 2 more action questions. One that is really difficult. So this one I'm now going to show you guys is really difficult. In the multiple years that I'm teaching this course, I never had a student that was able to solve it. So don't worry about it if you're not able to do it, because I've never seen a student that was able to solve this question. And after this question, we will do another action question, which is like the the normal level of the exam, and then we have a break. Because this exam, if question is, if you really want to get a 10, then you should be able to figure it out. If you can live with a 9.5, then this question is not for you. And the next question, that's like the normal level of the exam. The next question you should be able to do. But don't feel bad if you don't know how to do this. So each minute I will give you guys an extra hint. Just see if you are able to figure it out. Okay. First, you had to recognize, and by the way, I have two ways of teaching this problem. So I will first show you the way they do it in the summary. And then after that, I will show you another way to solve it. Maybe you find the second way easier. The first thing you have to see is that you have to apply the extending term rule. And that's already pretty difficult. So the extending term rule is xi plus maybe Sophia wants to finish it. What was the extending term formula again? Now I started I is. Just to give you guys the first hint, maybe Sophia can tell me what I have to write down here. You don't know? The n plus 1, right? And do you know what you should write here? Maybe you have it still in your notes. N plus m. And then here, I is 1 all the way up to n plus m. So this is just the formal definition of your extending terms property. So you could just remember that. And now I'm going to apply this formula here. So here I have a 1. Here I have the I. Here I have some value. And notice that this value here is not n plus 1. So maybe not a 1. So this summation I have to choose. What is this summation? Is it this one, of this one? So the first one, the second one, or the third one? What do you guys think? So again, this summation, is it the first one, the second one, or the third one? What do you guys think? Anyone have an idea?
Is it the first one?
The first one starts at 1, right? But this one doesn't start at 1, so it cannot be the first one. All right? So it has to be the second one. Do you see that? So the n plus 1 is A. That's the only option. So n plus 1 is A. Do you see that? Then what should I write down here, Francisca?
That A is I don't know.
That then this to A is the same as the n plus m, right?
Oh
You see
yeah,
that?
yeah. Mm-hmm.
So you have to see that this one is not A, this one is not A, So this thing has to be A. N plus 1 had to be A. That's the first thing you have to see here. Okay. Now, we know that N plus 1 is A. So what is the N? Then N is, does anyone know? N plus 1 is A, so N is?
A minus 1.
A minus 1. So now I can replace this N that we're seeing here. Let me do it in the red. This N, I can write down A minus 1. You see that? Is that also clear for you guys? Then this summation here, this is I is 1. And what should I write down here? Does anyone have a clue? Like I said, it's a really difficult axiom question, but just see what you know. So here I said N plus M is 2A. So now I again said N plus M is 2A, right? So do you guys see this step? This step was a really difficult step, but do you guys see that? Yes? What I want to know is this thing. So this red summation, that's the summation I want to know. Let's call this the blue summation. And let's call this the green summation. What I will do, I will now change the order. So now I have blue plus red is green, but I will now get the blue one to the other side. So I get 2A, I is A, I. So this is the red summation. I will get it to the other side. So here's the green summation. This is the green summation. And then minus the blue summation. Do you guys agree with that step? Are you guys still able to see the lowest row?
I only, where does the A minus 1 come from? I don't get that step.
Okay, good question. So you did see where the N plus 1 is A came from, right?
Yeah.
If I then get this 1 to the right, it will
Oh,
be
okay.
negative.
Okay.
N is A minus 1.
Yeah.
Other questions so far?
I'm trying to follow, but I will see at the end.
Okay. So now I have this red summation is the green summation minus the blue summation. You see that? Okay. So I just copy this red summation. And what I now can do is I can apply this trick here. So this trick is a trick that can be applied if the I is 1 and you have the I expression here. And that's what we have here. The I is 1 and I have the I. I is 1 and I have the I. So now I can apply this trick here. So I would just ask somebody of you to help me to apply the trick. Maybe Natalie wants to help me. So what is the N from this summation? From this summation here, what is the N?
29.
It's 2A.
Oh, 2A.
It looks a bit like a 9, but it's 2A. So indeed, so I can fill in for N 2A. Then here I get N plus 1, so 2A plus 1, and then divided by 2, right? So this is basically the green summation that we just saw. You agree with that?
Yes.
Now, oh, sorry, minus the blue summation. What is the N of the blue summation?
A minus 1.
A minus 1. So I write down a minus 1. That's the n here. And this one, you have to see, the n is a minus 1, but I do a minus 1 plus 1. So what do I get?
A.
Yeah, just a. So I can multiply it with a, and I divide it by 2. Is this step also clear for everybody? Yes? So now I apply this part of the information. Okay. From now on, you can use just some algebra to get the final answer. And maybe you can also help me with that, Natalie. 2a times 2a is
4A.
4a squared,
Oh,
right?
yeah.
Because also the a times a squared. And then 2a times 1 is
2A.
2a. And then minus the a times a
A squared.
squared. And then notice the minus minus, so it becomes positive, 1 times a.
A.
Yeah, just plus a. And since they have the same denominator, we can take those fractions together. So I just get 2 here. Okay, then we're almost there. 4a squared minus a squared is
4.
3a squared, right?
Oh, yeah.
And then 2a plus a is
3A.
3a. Now we can see what they have in common. Well, they all have a 3a divided by 2, right? And then times a plus.
I don't know.
That's 1. Because 3a times a is 3a squared. And 3a times 1 is this 3a. Do you see that?
Oh, yeah.
And that's your final answer. Really difficult exam question. Only for the people that want to have a 10 on the exam. Okay. This is the first way to solve it. Then you use the extending term property. Are there any questions about this first method? Then I will also show you the second method. No questions? I think it's pretty difficult, right? But don't feel stressed about it, because I never saw a student that could do this one. No questions? Okay. You can also see the solution in the summary. So here you see it yourself. Okay. Then I'm going to show you a different method. So we want to have this thing here, right? Let me take you to the whiteboard. So the question is, find the summation of I is 1, of I is a, all the way up to 2a, right? And then from I. That's what we want to know. And if we write a summation out, we know that it is a plus a plus 1 plus all the way up to 2a minus 1 all the way up to 2a. Do you guys agree that that's how the summation looks like? Do you guys agree with that? There is a nice trick that we have. So this is the second method to solve it. There's a trick that we have, and that is that if you get a summation like this, I is 1 all the way up to n, you can get n times n plus 1 divided by 2. Okay, so we want to do something with this trick here. And I think maybe this trick is easier for you guys. So we want to do something with this trick here. And this trick only works when the I is 1. So what we can do is we have to come up with some series that start with the value 1. So let me show you. What I could do is the following. I could make this green series, which is 1 plus 2 plus all the way up to a plus 1, all the way up to 2a minus 1 plus 2a. So that's the green series. And what I can do is I can subtract this orange series, which goes from 1 plus 2 all the way up to a minus 1. I will, by the way, add one term, 1 second. So to the green term, to show you, it actually goes like this. A minus 1. Okay. So do you guys agree that if I subtract this green series from, if I do the green series minus this orange series, do you guys agree that I end up with this blue series? So green minus orange is the blue series. Do you guys agree with that?
Yes.
The green summation is I. What's the starting value of the green summation? 1. And what is the ending value of it? What is the ending value? To see if you guys still follow me.
2a.
2a, right? And then I do minus this orange series here. What's the starting value of the orange series? 1, right? And then the ending value is a minus 1. That's another way to come up with it. So now you said the blue series that we want to find is the green series minus the orange series. And then you can again apply the trick. So you say, all right, for the green one, my n is 2a. So the n is 2a. 2a plus 1 divided by 2 minus, and then for the orange one, the n is a minus 1 times a minus 1 plus 1 is a divided by 2. This is also how you can end up with, how you can eliminate these summations. And then you can eventually solve this for, what was it? I think it was 3a divided by 2 times a plus 1, right? That's what we eventually end up with. But I will not show those algebra steps again. But do you guys also understand this method? Do you find this one easier? Or do you prefer the method from the summary? Which one do you like more? Or don't you understand both of them? That can also happen, of course. For example, you, Jason, did you understand it? Or is this a bit too difficult? Sorry?
Well, a bit difficult, but
A bit too difficult, right? Okay. No worries, because this is a really difficult question. I will now show you an exam question that is a bit more on the action level. Let me show you. Try to do this one. This is more like the action level. And after this one, we will have a break. You can send me the answer in the chat if you have it. Okay, I already see two answers. I think Vanshika has it correctly. Boris, you don't have a J, you should have a J in your final answer. Because the J, you don't know the value of J, so you just have a J in your final answer. Jason, would you want to do this together? Do you want to do it together? Jason? Maybe Boris then?
Sure.
Okay, so we have I is 3 all the way up to
Yeah.
5. And then 2 plus 3i minus 4j.
Yeah.
So what is the first value that I will have?
3.
3, and then it will be
Mm-hmm.
4,
And 5.
and then it will be 5, right? And what kind of sign do we put in between?
Plus.
Plus. Okay. If the I is 3,
It's
then this will be a 9, right?
it's 11 minus 4j.
Yes.
So I know what I did wrong.
Okay.
And
And then
it's
here you get 3
14
times. Yes, 14 minus
4j.
4j.
And 17
And it,
minus 4j.
yes. Now we take it together. 11 plus 14 plus 17 is
42, I think.
42. And then 4j minus 4j minus 4j
Minus 12j.
is minus 12j. Very good.
Okay. Yeah.
Thank you, Boris. Is this clear for everybody? Yes? Let's have a break then. And let's be back at 11:40. So, by the way, in the solution from the summary, I did it a bit more difficult to show you how you can use the properties, but this is fine. So if this is clear, we will continue at 11:40. See you then, guys. Hey guys, are you ready to continue? Okay, let's begin then. Maybe you can say it in the chat if you're back. Then I just have a clue. If you guys are here, yes. Okay. You guys are back. Great. So then the next thing what we're going to do is we're going from outcome to formula. So for example, you have a series like this, and you have to determine a summation from it. So first we went from summation to series, but now we go in the other direction. We start with a series, and you have to find the summation that corresponds to it. Well, if it goes all the way up to n, it's actually pretty easy. You can just take the last part, which is A, I, N, B, and J, and then you replace the n with an index of your choice. So you can use I, J, K, or whatever, but you have to pay attention. We already used the I and the J, so we cannot use that one. So we replace the N with, for example, the K. That's the next letter in the alphabet. Then you put a summation sign in front of it. And since I chose the letter K, I will start with letter K. Then I look, what is the first value that K will take? Well, first K will take the value 1. So I include the 1, and then I put an N here. And this is the summation that corresponds to this series here. Do you guys see that? So this is how you find the summation that corresponds to that series. So that's how you do it. Let me show you another example. And to do this question, I will ask one of you guys. Maybe Fonchika wants to help me with this.
Yeah.
So how do we start? I want to summarize this series into a summation.
So you would also have to replace the n then with another index, so you can make it k as well then.
Yeah, that's
So
fine. 4K.
And then you would write that summation sign. So then k is equal to 4. And
Yeah,
on
one
the
step, by the way. You would think it's 4, right? But if I put a 4 here, then I would
sorry,
start
1,
with
yeah.
16.
Yeah,
So I
it's
have
a
to
1.
do 1. Because if I do K is 1 here, then I get the 4. You see that? And if I do K is 2, then I get the 8. And what is then my thing that I put here?
4n.
No, just N, right?
Oh yeah, n, yeah.
Yes. You can check yourself. You can do K is 1, K is 2, all the way up to K is N. So now you get 4 plus 8, all the way up to 4n. You see that? Okay. Is this clear for you guys? Is this clear for everybody? Yes? Can I erase this?
It's clear. Are you gonna do more exercises of these type?
Yeah, I can show you another one. What if you don't have an n, for example? So for example, what if you have a series like this? 3 plus 6 plus 9 plus 12. This one is harder because now you don't have a last part that you can take. So here you have to look for a pattern. First, you have to determine, is it a summation or a product operator? Since we have pluses, we know that we have to do something with a summation, right? Let's just use index I. What do you guys think that the expression will be that I have to place here? Does anyone have an idea?
Would it be just I?
If it would be just I, then I would get 1 plus 2 plus 3 plus 4. So that's not it.
3i.
3i, because this is 3 times 1, this is 3 times 2, this is 3 times 3, this is 3 times 4. Do you guys agree with that? So it's 3i. And then what will be the n?
4.
The 4. Very good. So this is the summation that corresponds to that series. Is that clear for everybody? Do you want to have another one? Here's another one. 12 plus 16 plus 20. What is the summation that corresponds to it?
I is 3.
I is 3.
No. I mean the bottom is I is 3. It starts with I is 3.
Okay. How do we know that?
Because it's a form of 4. So every time 4 is added, and 3 times 4 is 12. So you start with 3.
Yeah, so 4 times 3, you say?
Yeah.
4 times 4 and 4 times 5, right?
Yeah.
So it starts with 3 and then 4i. That's what you're saying.
Yeah.
And then what will be the n?
5.
Yes, very good. Thank you, Boris. Is this clear for everybody? Yes?
So is there like a shortcut or something you can do to make it easy for you to recognize these patterns? Because sometimes I just think a lot and I can't come up with the
Yeah,
right one.
I understand. The thing here is that you should look for patterns. So it goes in steps of 4, right?
Mm-hmm.
Then you always have something with a 4 in it. You see that?
Mm.
And then you're looking for a number that goes in steps of 1. That's the I part. That's basically what you are looking for.
Okay.
Here
Okay.
I will make a more difficult one. Jason, would you like to help me with the next one?
Yeah, sure.
3, 9, 27. And then I think the next one is 81. And then a plus, of course. Pretty important. Did I forget it here? No. Okay. 3 plus 9 plus 27 plus 9, 81. What is the pattern that you're seeing?
I
Or
thought
do you want to
times 3,
answer?
but
Yeah, it goes times 3 times 3 times 3, right?
yeah,
Do you want to have an extra hint?
yeah,
This is 3 with the power of 1. This is 3 with the power of 2. This is 3 with the power of 3. And this is 3 with the power of 4. So I have a summation. I is 1. Sorry, I is, what is the starting value of the I, you think?
1,
1. What is the ending value, you think?
4,
4. And what will be the expression here? It has to have something with a 3 in it, right?
yeah,
And then with the power of
1,
I.
I,
Do you agree with this?
yes,
Now
I,
you will get this expression.
okay,
Very good. Is this clear for you guys? Yes? Okay. Do you guys want to have a more difficult example?
Yes.
Okay. Mm. Four times 5 times 6. Do I have to use a summation or a product operator here?
Product.
Product operator, because we're using the time sign. Okay.
And then I is 4.
I is 4. I'm not sure about that.
Oh no, I
so
is 1.
Yeah. So I would always start to make the row that you have into a row like this, so that you can already see the structure in it. So can you convert this into a row in which you can more easily see the pattern? I think it is 3 plus. To get this 4, it's 3 plus
1.
1. And to get this 5, it's 3 plus
2.
2. To get this 3, it's 3 plus 3, right?
Mm-hmm.
So I is
1.
1 all the way up to
3.
3. And this here is
3 plus I.
yes, very good, Julian.
Okay.
Is this clear for you guys?
I have a question about it.
Yes.
Why isn't it possible to have the product and then on the top it's 6 and then I is 4 and then just I?
So here 4.
Yeah, and there's 6.
And here 6. Oh yeah.
Because then you
That's
get
actually easier. I want to come up with an example where that was not available. I'm sorry, I was thinking too difficult. I want to come up with a difficult example. I'm sorry for that.
no problem. But this is also possible.
Yes, but what you do is way more easy. I'm sorry. I was looking for something like that where this was needed, but that was here it didn't make sense. What you are saying is better.
Okay.
Okay. So this is a better solution. I was looking for a difficult example and I thought too difficult. Okay, thank you. Is this question clear for you guys? Are you guys able to convert a series into a summation? Is that clear? Yes? Let's go back to the PowerPoint then. We're going to finish it off with double summations, and then we're done for today. What do you guys think about double summations? Do you find them difficult or do you find them easy? Are you already familiar with them?
I find them a bit difficult, to be honest.
Yeah, I understand that. So let's see if we can make a difference, if we can bring a difference in that. So I would just take the examples from the slide. If you have, for example, the summation, what is it? I is 1 all the way up to 3, and then j is 1 all the way up to 4, and then I times 3 with the power of j. What you will do is you will first solve the summation on the right. So we can just copy the left summation. And then we first get rid of the summation on the right. So what the summation on the right will go from j is 1, j is 2, j is 3, j is 4, right? And since we have a summation on the right, another product operator, you will get pluses here in between. Okay. And then you look at the expression. Here you will get a j of 1, so I times 3 with the power of 1, I times 3 with the power of 2, I times 3 with the power of 3. And here you get I times 3 with the power of 4. Does this first step make sense to you guys? Yes? Then we're going to simplify it. So you always start by working out the summation or the product operator on the right. So let's see if we can simplify it. I copy this summation here. And then I have the following. I have I, and I. So I can get this I out of the brackets, right? And then I get 3 with the power of 1 plus 3 with the power of 2 plus 3 with the power of 3 plus 3 with the power of 4. Could somebody plug this part into his calculator? Could somebody do that for me?
$120.
Yes, 120. So I get 120 I here. Is this clear for you guys? So is it clear how we just copied the left summation, we worked out the right summation, we simplified, and we now got this here. This is, by the way, the most difficult part, because now you have reduced your problem to just one simple summation. So from here on, I think you know how to do it. Maybe Sterre can tell me how I proceed.
Sorry, could you repeat what you said?
Do you know how I have to continue? So I now ended up with this. And how can I now continue? Because now it's just a single summation.
I have no idea. I'm sorry.
So you start with I is 1, I is 2, I is 3, right? To solve this summation.
Oh, you just want to solve it. That's fine.
Yeah, and then I
Okay.
get
120 times 1 and plus 120 times 2 plus 120 times 3.
exactly. And if you take that together, what do you get?
720? 720?
Yes. Yeah, very good. And that's how you solve a double summation. So you first work out the right one, you simplify, and then you solve the single summation, like you always are doing. Okay. Is this clear for you guys? Let me change things up a bit. So here we said that this summation is a summation and not a product operator. Let's see what would change if we make it a product operator. Can I erase this? Okay. So we started with I is 1 all the way up to 3. And now I will make this a product operator from j is 1 all the way up to 4. And we had 3i times 3 with the power of j. Okay. Adam, would you maybe want to help me to solve the product operator?
Yeah, I can try.
So it started at j is 1, j is 2, j is 3, and j is 4, right?
Yes.
And then I can just copy the left summation. I will turn this a bit to the right. So I can just copy the left summation. And my question is, what kind of signs do I put in between here? Because we now had a product operator on the right.
The multiply.
Yes, the multiplication sign.
Yes.
And then if j is 1, what do I get here?
If j is 1, you get I times 3 to the power of 1.
Yes. And if j is 2?
Yeah, to the power of 2. And so on,
And
so
then,
on.
exactly. That's the first step. Now we're going to simplify it. So I can just copy the summation. I is 1, 3. And let's see if you know the algebra rules. I times I times I times I. What will that be?
I times 4i. No, I to the power of 4.
Yeah, so this times this times this times this is I with the power of 4. And do you also know the rules for this? 3 with the power of 1 times 3 with the power of 2 times 3 with the power of 3 times 3 with the power of 4.
I don't know what exact rule you're talking about, but I know it's not that hard the answer, because it's 3, 9, 27, 81.
Yeah, exactly. But the algebra rule is that you can now add the powers of the blue numbers.
Yeah.
What is the
Yes.
sum of the powers?
The sum of
That
the
is
powers.
3. So 1 plus 2 plus 3 is
3,
4.
6, it's 7.
It's 10. So 3 plus 4 is 7, plus 2 is 9, plus 1 is 10.
Oh,
You see that?
yes. I forgot the 4. Yeah.
Okay.
Yes.
There you go. And if you want, you can put this in your calculator, but you don't have to. I think you get a really big number. So now we have to solve this summation here. How would you solve that summation?
I know I is 1.
Yes. Then I is 2. Then I is 3. And what kind of
Yes.
sign do I put in between? Sorry?
Here you use the plus.
Yes, because this is a summation sign.
Yes.
So because this one was a product operator, we do a times in here. And because this is a summation sign, we do a plus sign here. Okay.
Yes.
So I get 1 with the power of 4 times 3 with the power of 10. Then 2 with the power of 4 times 3 with the power of 10. And then 3
3
with
to the power of 4. Yes.
Okay. Yeah, you could in theory put this into your calculator. You could also simplify it even more. Then you get 1 with the power of 4 plus 2 with the power of 4 plus 3 with the power of 4. You can also put that into your calculator. And what do you then get?
I'm gonna calculate it. Let me see where my calculator is first. Yeah, you get 5,786,802.
Perfect. So
Yes.
is it clear? Yes. Is it clear for everybody how to solve a double summation? Is that clear for everyone? Okay. If that's clear, I'm going to show you a different way to look at double summations. And especially a way that you will use a lot in this course. Because sometimes you can have that you want to have a table and you want to add all the elements from a table. And if you have a table, you always want to use a double summation. So I will show you. So another way to see a summation is like this. I is 3, I is 1, all the way up to 3. And then j is 1 all the way up to 4. And let's do I times j, for example. It could be anything. Another way to look at this is that you are seeing it as a table. So I is 1, I is 2, I is 3. And then the j will indicate the column. So j is 2, j is 3, j is 4. So what you will get here is that you get a table with 12 elements, which we will all add together. That's another way to look at this double summation here. Okay. What should be on this spot then? Anyone knows? I think you maybe know it. Here you get a 1 times 1. Here you get a 1 times 2. Here you get a 1 times 3. And here you get a 1 times 4, right? Let's see if we also know what should be in this spot. Here you get 2 times 1, 3 times 1. What should I get here? What all the other spots? So for example, here I should get a 4, right? And here a 6. And here 2 times 4. What should I get here, guys?
A 6,
A 6.
9,
A,
and 12.
yes. What you now can do, you can take those numbers together. And then you get 1 plus 2 plus 3 plus 4 is 10. This together will be 20. And this together will be 30. And then we can take this together to get 60. Do you see that? So now we know that the summation here is 60, for example. So you can basically see a double summation as a table. Okay. So here I have another question. Did you guys copy this? Here I have another question. And now I have a table with A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, and A34. The question is, find a formula that adds all those elements together. So this is basically my table. You can see this as I is 1, I is 2, I is 3, J is 1, J is 2, J is 3, J is 4. And you have to find a formula that adds all those elements together. How would you do that? Anyone? If you want to add all the elements of a table, what do you know? You always have to use double
A double summation.
summation. And then the I goes from 1 to 3, right? So from 1 to 3. And the J goes from 1 to 4. And what is the index sign of the I and the J? what should be here? Maybe you see the pattern. I and J. Do you guys understand this?
Yes.
This is the answer. So let's see if you see the similarity. So this 3 is the number of rows that you have, 3 rows. This 4 is the number of columns that you have. And the Aij, that's the thing that changes from the values. Is this clear for you guys? Before I'm going to show you an action question. Because you probably have never seen this before. But I hope you see what I did here.
I
Are there
only
any
don't
questions?
get. I have a question. I
Yeah.
only don't get how they get on A11, A12, A13, A14 now.
Or, so everything you see above was given. So
Okay.
that was all given. And you had to
Oh.
come up with this thing here in the question. So everything above the line was given to you. And you had to come up with the answer here below. That's the idea here. Would you be able to come up with that answer?
Oh, it's not an 11. It's just 1 and 1 together.
Yeah, it's 1, 1, 1,
Oh,
2, 1, 3.
Oh, should there be a comma in the middle or? something?
No, because you don't put a comma here, so then you also
Oh.
don't put a comma here.
Okay. No, I understand now because I thought it was 11 and I was like, huh? Oh.
No,
No,
exactly.
now I
No,
see.
it is. So the left number indicates the
Yeah.
row, and the other number indicates the
Column.
column. You see?
Okay, I understand. Thank you.
Okay, very good. Any other questions or things you find strange? Okay. Then here, I have an action question. Just take your time to read it. This was an old action question. And I think this is the last question from the summary, if I'm correct. Do you guys understand the question? That's the first thing, because that can be difficult, right? You get a story like this, the whole text. What do they want from us? Okay. Tell me if I can clarify something. Okay. Tanish, would you like to help me with this question?
Oh, yeah, sure.
Do you have an idea what they want?
Yeah, I think if you just start by doing the steps you did before. So they're saying they have 5 rows and 7 columns. So you write that down as a table.
Okay. I think that's a lot of work, but
Yeah,
I
so
think
just
it
to
can be
skip.
helpful to do that.
Yeah, so
Like this,
basically
right?
just write the
I will also
summations
skip this
and
here. And then it will be P11, P12, all the way up to P17, P21, P51, P22, P27, P52. So you have to imagine a whole table. like this, right?
Mhm.
And then we want to add all the elements from this table here, right?
Yeah.
How can I do that?
I think you do a 5 summation I equals 1.
Yes.
And 7 summation j equals 1. And then pij.
Yes, perfect. Full points. And then you have to write down that's the total production of energy. So all the elements together, that's the total production of energy in this example. Very good. Is this clear for you guys? That this is the answer? Or are there any questions? Very good, Denise. Then that's it for today, I think. So that's the end. So then the only thing that I can say is, if you did like this session, you can register for the weekly course. This should be IBA. Or you can scan the QR code. I think the QR code is working. Maybe you can try it. Do you indeed get to the IBA page? I think the QR code is working. And there's now a temporary 10% discount on the website. And if you're a member of Arius, you get 15% extra. So they have 25% in total. So if you want to have the full course, then I might see you next week. And else, good luck with your studies, guys. All right.
I
If
have
there
a
are any other
question.
questions, I'm just here. Yes?
Yeah. There are two courses, like the ones from lessons 2 to 6 and the ones that are like Wednesday 12.5 hours.
So let
It's
me,
just
I
different
can
timing.
also go to the website. Let me show you. I will tell you what the difference is. So this here, those are the English sessions.
Mhm.
And those are, by the way, at the Vrije Universiteit. So then they're not via Zoom, but they're just at the university.
Okay.
And this here, this one is in Dutch. You see that? So if you're Dutch, you can just go to this session. And it's also at the Vrije Universiteit. So for you, Sterre, I think you're Dutch. You can
Yes.
choose, right? Because you understand English and Dutch. So you can just choose which one you want to go to. Okay.
Sure. Okay, thank you.
All right. Any other questions? No other questions? All right. Good luck, guys. Maybe to next week. And else, good luck with your studies.
Thank
Bye,
you.
guys.
Bye.